During the Japanese colonial period, the Kaohsiung-Pingtung area's waterworks included the Dagou Waterworks, Pingtung Waterworks, Qishan Waterworks, Gangshan Waterworks, and Fongshan Waterworks. The Dagou Waterworks is the modern-day Kaohsiung Waterworks, which is divided into the Kaohsiung First Headwater Point and the Kaohsiung Second Headwater Point. The Kaohsiung First Headwater Point consisted of the Julia Water Intake Station, Zhaopingding Headwater Point, and Cishan Distribution Reservoir. This was Kaohsiung's earliest waterworks, completed in 1913, and the water was drawn from the Lower Danshuei River, which was an essential water source for the Kaohsiung metropolitan area at that time. The Kaohsiung First Headwater Point primarily supplied water to the urban area west of the Love River. The Kaohsiung Second Headwater Point consisted of the Wongongyuan Water Purification Station and the Cao Tan Distribution Reservoir, completed as an expansion in 1942. It sourced water from the underground flow of the Lower Danshuei River. The Kaohsiung Second Headwater Point mainly supplied water to the urban area east of the Kaohsiung River. The Pingtung Waterworks, formerly known as the Dagou Waterworks, was completed in 1917. It initially shared water sources and purification facilities with the Kaohsiung Waterworks, drawing purified water from the Zhaopingding Headwater Point. However, due to insufficient water from the Kaohsiung First Headwater Point, a new headwater point was established on the east side of Pingtung City in 1938, including the drilling of wells and the installation of additional waterworks facilities. This allowed the Pingtung and Kaohsiung Waterworks to operate independently. The Qishan Waterworks was completed in 1925. Due to Japan's financial difficulties at the time, it was funded by private organizations. The water source was drawn from the Qishan Canal of the Nanxixian River and channeled into the waterworks through the canal, bringing a continuous supply of water to Qishan Township. The Gangshan Waterworks was completed in 1925, sourcing its water from the Baijia Canal of the Agongdian River. In 1937, an elevated water tower was added, which became a landmark in Taiwan's architectural history. The Fongshan Waterworks was completed in 1925, sourcing water from 3 underground collecting wells. The towering water tower and aeration tower, which sprayed water, were landmarks of the Fongshan area. The Kaohsiung Waterworks, originally called the Dagou Waterworks, completed its first headwater point in 1913, with water sourced from the Gaoping River. The construction of the Dagou Waterworks was initiated by the Japanese government to meet the urban development needs associated with the construction of Takao Port. In 1909, the Taiwan Governor General's office set up a water intake point on the right bank of the Lower Danshuei River in Julia Village, Dashu Township, to draw water from the river. Additionally, a water purification station was established 3 kilometers away in the hilly area of Zhaoping Village, and a distribution reservoir was constructed on Shoshan. When the Dagou Waterworks was first established, its scale was second only to the Taipei Waterworks, making it one of the 2 largest waterworks systems in northern and southern Taiwan at that time. The Julia Water Intake Station, originally named the Dagou Waterworks Pump Room, was completed in 1913. The station included a collecting well, water intake point, pumping well, and pump room. The pump room, built with a wide-span wooden structure, provided a spacious interior equipped with modern power-driven pumps. In 1998, it was designated as a Grade 3 historical site by the Ministry of the Interior, and it is now a municipal monument in Kaohsiung City. The Zhaopingding Headwater Point, located in Zhaopingding, Dashu Village, was completed in 1913. The site included facilities such as a distribution well, sedimentation tank, sedimentation well, sand filter, sand filtration well, water conveyance well, and sand washing area. After the retrocession of Taiwan, the site was taken over by the Kaohsiung City government and renamed Kaohsiung City Water Treatment Plant First Headwater Point. Covering an area of about 25 hectares, it was renamed the Pingtung Water Purification Station in 1974 and integrated into the Taiwan Water Corporation as one of the 6 purification stations serving the greater Kaohsiung area. The Qishan Distribution Reservoir, also known as the Dagou Water Purification Pool, was completed in 1913. The reservoir housed facilities such as a water purification well, water purification pool, valve well room, and water meter room. It primarily received and stored purified water from the Xiaopingding headwater point, which flowed through the valve well room to the water meter room at the foot of the mountain and distributed water to the urban area. Additionally, an underwater pipeline was laid at Zhixia to extend water supply to Xijin and provide water to the urban area of Qiho. The purification process at the Kaohsiung first headwater point began by collecting raw water from the Lower Danshuei River into a collecting well at the water intake station. After water was drawn through the water intake point and into the pump well, the pump was used to lift the water to a height of approximately 59 chi, where it reached the distribution well at the Xiaopingding headwater point. After undergoing sedimentation, filtration, and disinfection, the clean water was first collected in the conveyance well. Then, using the natural gravitational drop of 120 meters, the purified water was transported to the Dagou Water Purification Pool located on the South Shoshan at an elevation of 34.8 meters, supplying water to Dagou Port and the urban area. As factories and heavy industries rapidly developed in the Kaohsiung area, the demand for water significantly increased. In 1942, the second headwater point was established in Wongongyuan, Daliao village, to collect groundwater using collecting wells. Additional facilities such as aeration basins and sand filters were installed, and a distribution reservoir was built on the hills of Kaohsiung and Daliao to supply water primarily to the areas east of the Kaohsiung River. The Wongongyuan water purification station, located in Daliao village, was completed in 1942, with a designed output of 8,350 cubic meters per day, capable of serving 50,000 people. After being taken over by the Kaohsiung city government in 1945, the plant underwent continuous improvements and expansions, and it now has a designed output of 36,000 cubic meters per day. The Kaohsiung Distribution Reservoir, located on the hills of Kaohsiung and Daliao, was completed in 1942. It primarily distributed purified water from the Wongongyuan water purification station to the Kaohsiung area. After the completion of the Kaohsiung water treatment plant in 1972, the distribution reservoir was decommissioned and no longer used. The Pingtung Waterworks, also known as the Dagou Waterworks, was completed in 1917. Its purpose was to meet the local residents' water needs and improve environmental sanitation. Initially, the water source and purification facilities of the Pingtung Waterworks were shared with the Kaohsiung first headwater point. After the water was filtered at the Xiaopingding headwater point, it was transported via the Dagou Waterworks water meter room and the Lower Danshuei River railway bridge to the Dagou urban area for residential use, with a planned supply for 15,000 people. As Pingtung's population grew and the water supply from the Kaohsiung first headwater point became insufficient, a new headwater point was sought for the Pingtung Waterworks in 1934. The eastern side of Pingtung City, in the Changxing area, was selected for test well drilling and water quality testing, which revealed that the groundwater was both high quality and abundant. Thus, in 1936, Changxing was established as the new headwater point, and the expansion of the Pingtung Waterworks was completed in 1938, allowing the Pingtung Waterworks to operate independently from the Kaohsiung first headwater point. The Pingtung Waterworks sourced water from collecting wells. The raw water passed through aeration basins and flowed into sand filters for purification. After filtration, the water was pumped from the pumping well to a distribution tower 30 meters high. The purified water then naturally flowed downward by gravity to supply 45,000 residents in the Pingtung urban area. The Qishan Waterworks was built in 1925. Due to financial difficulties following the 1923 Great Kanto earthquake, the Qishan Waterworks was initially funded by private investment. The Qishan Credit Union signed a water supply agreement with the Irrigation Association, where the credit union was responsible for constructing the waterworks facilities and the irrigation association provided the water from the Qishan Canal of the Nanxixian River. Once the waterworks were completed, ownership of the facilities was transferred to the irrigation association, which paid a usage fee to the credit union. The Qishan Waterworks was the earliest modern water supply system built in Kaohsiung County at that time. In 1929, due to the irrigation association's unstable water supply and the credit union's insufficient financial resources, the local government purchased the Qishan Waterworks system and made improvements using public funds. A water purification pool was added in 1930. After 1945, as the population of Qishan increased and the Qishan Canal began to experience reduced water flow due to poor maintenance, the facilities gradually became insufficient to meet demand. In 1954, a new water intake point was established at the Qishan embankment, and an 850 cubic meter water reservoir was added at the foothills of Zhongshan Park. The Qishan Waterworks was decommissioned between 1961 and 1971. In 1975, the filtration facilities were converted into a children's swimming pool, which was later abandoned in 1996. In 2001, there were plans to demolish the water purification pool and build a social welfare building in its place. Fortunately, after strong efforts from local residents, the water purification pool was preserved, and a social welfare building was built nearby. In 2004, the water purification pool was registered as a historic building. The Qishan Waterworks facilities included the Qishan Canal water diversion channel, sand filter, and water purification pool. The Qishan Canal was the source of water for the Qishan Waterworks. The water diversion channel was inverted trapezoidal, with a sluice gate installed at the top to block the water and direct it into the water intake point. The sand filter was made of reinforced concrete. When the waterworks were completed in 1925, the facilities were relatively simple. Water from the canal was filtered, and the natural water level difference was used to send water through distribution pipelines to the homes in the town. Initially, the Qishan Waterworks did not include a water purification pool. After the government acquired and upgraded the waterworks in 1929, a water purification pool was added in 1930 below the sand filter to improve water quality. The water purification pool was covered with soil and had 6 ventilation shafts on top, along with a front chamber at the entrance. The commemorative monument was erected in 1925 after the completion of the Qishan Waterworks to honor the contributions of the Qishan Credit Union and Irrigation Associations, whose investments made a lasting impact on the economic development of Qishan. The only remaining facilities from the Japanese colonial period Cishan Waterworks are the Qishan Canal Sluice Gate, the water diversion channel, the water purification pool, and the commemorative monument. The water purification process of the Qishan Waterworks began by diverting water from the Qishan Canal. The sluice gate blocked the water, and it was collected through the water intake gate. The water was then channeled through the diversion channel into the distribution reservoir, where sand could be washed if necessary. The distribution pool directed the water to 3 sand filters. After filtration, the water was sent to the clear water reservoir, which then transported the water to the purification pool for storage. From there, the purified water was distributed through pipelines to the urban area for residential use. The Gangshan Waterworks was built in 1925, with its water source drawn from the Baijia Canal of the Agondian River. Initially, it was a simple waterworks system, but as the population in Gangshan Street grew, an expansion project took place between 1937 and 1938. An elevated water tower was constructed to provide pressurized water distribution, supplying municipal water for 7,000 people in the Gangshan area. Subsequent expansion projects for the Gangshan Water Purification Station were carried out in 1957 and 1962. During these phases, the slow sand filter was replaced with a rapid sand filter, and a pump room was built to replace the function of the water tower for pressurization. The Gangshan Water Tower was converted into a high-pressure backwash system for the rapid sand filter. The Gangshan Waterworks facilities included a raw water well, sedimentation tank, sedimentation well, sand filter, pumping well, and storage tower. The Gangshan Water Tower is a reinforced concrete structure, approximately 30.9 meters high with an inner diameter of 5.4 meters and a water depth of 3 meters. Its full water level reaches an elevation of 25.4 meters, and it has an effective capacity of 113 cubic meters. The tower contains a water level gauge, and the main structure remains intact. The water tower was permanently decommissioned in May 1992, and in 2004, it was declared a historic building. It is one of the top 10 historical buildings in Kaohsiung County and among the 100 notable historical buildings in Taiwan, serving as an important landmark in the Gangshan area. The Fongshan Waterworks, located by Chaitupi, began construction in December 1933 and was completed in October 1934, taking only 11 months. The water source for the Fongshan Waterworks came from 3 underground collecting wells, 1 at the headwater point and 2 at Chaitupi. The maximum daily output was 2,400 cubic meters. The Fongshan Waterworks facilities included collecting wells, a pumping well, a pump room, a spray pool for interconnected sand filters, sand filtration wells, a sand washing area, and an elevated water tower. The Fongshan Waterworks originally functioned as an independent system using water from the underground collecting wells at Chaitupi. In 1972, due to water pollution at Chaitupi, the waterworks ceased drawing water from this source, and the supply was shifted to the Pingtung and Wangdangyuan water purification stations. The aeration tower was dismantled in 1984. The land containing the Chaitupi headwater point, sedimentation tank, aeration tower, sand filters, and collecting wells was returned to the Fongshan City Office in 1973. The reclaimed land has since been redeveloped into congregate housing. Currently, only the office area of the Fongshan Service Center remains, with the site area reduced from 1.2 hectares to 0.19 hectares. The elevated water tower of the Fongshan Waterworks was once a landmark of Fongshan and a shared memory of the older generation. However, after being damaged by the 9/21 earthquake in 1999, the tower was dismantled in 2000 for safety reasons and replaced by a parking lot. The construction of waterworks in the Kaohsiung-Pingtung area during the Japanese colonial period effectively addressed the issues of unclean drinking water and poor sanitary conditions, which had led to epidemics. These waterworks laid a critical foundation for the development of the region. Starting in 1909, the Taiwan Governor-General's Office successively built the Kaohsiung Waterworks, Pingtung Waterworks, Qishan Waterworks, Gangshan Waterworks, and Fongshan Waterworks. These structures were grand and meticulously designed, and despite over a century of history, they still retain their original splendor, holding a special place in the memories of local residents. The construction of waterworks was a revolutionary and universal engineering achievement in the development of modern cities, and the topic of public water supply is one worthy of deep exploration. As we enjoy the benefits of clean water today, we are reminded to honor the efforts and contributions of those who came before us, whose work continues to inspire gratitude and admiration.